In today's video, we're answering this specimen paper for Edexcel GCSE 9-1. It's a physics paper, paper 2. We're going to be doing a complete exam walkthrough and I'll be filling in the answers as we go. Question 1. Figure 1 shows part of a roller coaster ride seen from the side. The roller coaster car rolls down towards P. The car has a mass and velocity. Which of these is the correct equation for calculating the kinetic energy of the car? So make sure you've learned all the essential equations that you need. Kinetic energy is given by half mv squared. So let's look for that here. Yeah, it's option C. So that is the correct answer. The mass of the car is 580 kilograms. The car gains 39,000 joules of gravitational potential energy as it climbs from P to Q. State the equation relating change in gravitational potential energy, mass, gravitational field strength, and change in vertical height. Yet another mark for learning an equation off by heart. Here it is, GPE equals mgh. So let's write that out. So gravitational potential energy equals mass times gravitational field strength, which you can write as G, times change in vertical height. Part 2. Calculate the height h shown in figure 1, and we've been told that gravitational field strength is 10, so this is the equation we're using. We know that we have a GPE of 39,000, so I'm substituting that in there. The mass we've been told is 580 kilograms. G is 10, and we're looking for the height. Sort out this equation. Sorry about the beeping, but honestly, I live in London and there's just noise all the time. So if I had to wait until it was totally silent every time I filmed, we'd never have any videos. Okay, to work out h, you need to divide both sides by 5,800. And you get a value which is 6.7 meters. Obviously, feel free to rearrange that equation first of all. You could have done it this way. So h is given by GPE over mg. It's up to you, whichever way you prefer to do it. I always prefer to substitute the numbers in first. C. The car enters a pool of water at R. It slows down and stops at S. Describe how the total energy of the system is conserved as the car travels between R and S. So have a look at the path of the roller coaster car. I mean, this is a fairly standard answer. You need to state first of all that work is done against friction, and then the energy is converted to another form, such as thermal energy in the water, as shown on the diagram, or it could be gravitational potential energy of the water as well. So either of those options is the correct answer. So state first of all that work is done against friction and energy is converted into another form. E.g. thermal energy of the water. Question 2. Figure 2 shows a tank for holding water. The tank has sides of 2.4 meters, 2.1 meters, and 1.5 meters. The pressure at the bottom of the tank is 12 kPa. Be careful with units. The standard SI unit for pressure is pascals, so I'm going to convert that straight away. State the equation relating pressure, force, and area. Here's my formula triangle, which is FAP, and therefore force equals, if we cover the letter after, so after F, you can see it's area times pressure. It doesn't matter what way round you provide that equation, by the way. Calculate the weight of the water in the tank. It's really essential that you know that the unit for weight is newtons, which is the same as force, which is why you can use that same equation that we've just written to work out the weight of the water in the tank. And because I'm doing a talk through, I'm going to write out my exact working. So we obviously need to find out the area. The crucial area is this area highlighted here. So to work out that area, we do 2.4 multiplied by 1.5 to get an area of 3.6. Then we can substitute in that value as 3.6 multiplied by that pressure, which I've already converted to pascals. And once you've done that, you get a weight of 43,200 newtons. So as you've seen, we've got to be very careful with units here. Part 3, which diagram shows the direction of the forces from the water on the inside of the tank? You need to know that pressure acts equally in all directions, and it's the particles colliding with the container surfaces which actually creates that pressure, which is why B is the answer here. Figure 3 shows 3 containers, A, B and C. Each container contains a liquid as shown, so A contains water, B contains mineral oil, C contains water. There's some data about the liquids and the containers. Explain which container has the highest pressure at the bottom and which container has the lowest. Use information from figure 3 and figure 4. So in order to answer this question, let's look at this equation I've just written out, which states that pressure due to a column of liquid is the height of the column times the density of the liquid times the gravitational field strength. That obviously won't change the gravity, it's 10 on Earth. What it's saying therefore is the greater the depth of liquid and the greater the density, the higher the pressure will be. So as you can see, A will obviously have a greater pressure than C, and that's because the height of the water is more. And then if we look at the comparative densities, you can see that mineral oil has a lower density than water. So that puts itself below water in terms of density. So based on the fact that the water in A is the deepest and that it has a higher density compared with mineral oil, this means that A will have a greater pressure. So let's make that first statement. Pressure in A is the highest because it is the deepest and water has a higher density than mineral oil. If we compare A and C because they contain the same liquid, we know that pressure of A will be greater than C because it is double the depth, so we do need to point that out. So the pressure of A is twice that of C. And then lastly, let's state the equation, which is that pressure equals height times density times gravity provides evidence for the above. It's always good to state equations. When the depth of the liquid and its density increases, pressure increases. Three, a student investigates how the resistance of a thermistor varies with temperature. Remember, a thermistor is a temperature-dependent resistor. It looks like a hockey stick. The student sets up the circuit shown in figure 5 to measure the current and the voltage. He finds that it does not work. Let's have a quick look at what we have here. This is a variable resistor. This is an ammeter. This is a voltmeter. This is a thermistor. And this is a battery made up of 2 cells. This is a switch. It's really important that you learn all the electrical components so you can recognise what you have in your circuit. Give 3 modifications the student should make to the circuit so that the circuit works correctly. So as well as knowing the circuit symbols, you also need to know how you should be attaching each of these components. The crucial thing here is the voltmeter here should always be in parallel. It's not, it's been attached here in series, which is why we have a problem. The ammeter should be attached in series. Because it's been attached as a separate branch, so it's been attached in parallel, there's major issues here. And then lastly, looking at the cell, the negative terminal and the positive terminal should be next door to each other. So it should look like this. How they've drawn it with the 2 positive terminals side by side means that it will not work. So let's make all of these comments now. So the modifications, add the voltmeter in parallel. Secondly, add the ammeter in series. And then lastly, you want to swap the terminals on the cells. B. The student uses the equipment shown in figure 6 to measure the temperature of the thermistor. Give one reason for using the water bath. This question could come up in biology. It's to ensure that the temperature remains constant. The equipment shown in figure 6 is for investigations in the temperature range from 20 degrees to 100 degrees Celsius. State one way the student could develop this experimental procedure to investigate temperatures outside this range. I think it's because water boils at 100 degrees, which is why they can't go any higher. So potentially if you used a liquid with different boiling points, you could investigate temperatures outside of this range. The student takes measurements for two other components, A and B. The results for both of these components are shown in figure 7. So we have resistance being plotted against temperature for both components A and component B. Compare and contrast how the resistances of component A and component B vary with temperature. So really you need to say how they're similar and how they're both different. So as you can see in both, the resistance of both changes with temperature. So the resistance decreases for A as temperature increases, and for component B it behaves in an opposite way in that its resistance increases as temperature increases. So that's certainly a difference between the two. And you can also make a point about data. So if you look at the graphs, you can see that both have the same resistance at 80 degrees, which is 5,000 ohms. So let's get that written down. That made me jump. Component A is connected to a 12-volt supply, so that's obviously voltage. Which of these is the current in component A when the temperature is 80 degrees Celsius? So we're looking for the current, which is I. We've been given the voltage, which is V. And we need to use this piece of information here, that the temperature is 80 degrees. Make sure you're looking at the component A graph. At 80 degrees, you can see that the resistance is 5,000 ohms. So resistance is 5,000 ohms. In terms of the formula triangle you need here, it's VIR, which states that current is voltage divided by resistance, which is therefore 12 divided by 5,000. So in terms of picking between A, B, C or D, I can see that B is the correct answer here. 4. Figure 8 shows an airport worker refuelling an aircraft. Pumping fuel into an aircraft can be dangerous. The worker connects an earth wire to the aircraft before pumping fuel. Give one reason why earthing reduces the risk of fire, and that's because the earth wire discharges the excess charge to prevent sparking, which would lead to the fuel igniting and could cause a huge explosion. Explain how an aircraft can become electrically charged as it flies through the air. This is a really basic static electricity question. How does static electricity get created? Well, it's due to the transfer of electrons caused by friction. And this is the sort of answer in my revision guide all day long. These questions, they look different, they're all the same. So state, there is friction between the aircraft and air, which causes electron transfer between the aircraft and air. Fuel weighing 230,000 newtons is pumped into the aircraft. This fuel moves upwards to a vertical height of 4.7 meters. The power developed by the pump is 1,600 watts. Calculate the time needed to refuel the aircraft. The power developed by the pump is 1,600 watts. Calculate the time needed to refuel the aircraft. So it's really essential that you identify all the information you've been given. So because this is in newtons, it's either force or weight. We have a height here. We have power. And we're being asked to calculate time. So we need to try and work out which equations we'll need. Now, the equation linking power and time looks like this. And that states that energy is power times time. However, although we need to find the time, we've been given the power, we don't know the energy yet, so we need a different equation which will enable us to find the energy, and this equation is going to be GPE equals mgh, which states that gravitational potential energy, so a type of energy, is mass times gravity times height. So let's do that calculation initially. We know that the mass, well, hopefully you know that weight equals mass times gravity, and therefore mass is weight divided by gravity, which is therefore 230,000 according to the question, divided by 10. So therefore mass is this number, times gravity, which is 10, times height, which is 4.7. You can hopefully see that this is actually the same number, but I just wanted to go through the steps properly. Once we pop that into our calculator, we get this value. So that is the energy. Then we now need to look at this formula triangle. We're after time, so we can see that time is given by energy divided by power. Our energy we've just calculated. The power is 1,600 watts. Put that into your calculator and you get a time which is 676 seconds. That was an awful lot of work for not very many marks. C. Figure 9 shows an electrostatic method for spray painting a car door. The car door has a negative charge. The droplets of paint receive a positive charge as they leave the spray gun. Explain how charging the door helps the paint to form an even coating on both sides of the door. You should use ideas of forces and fields in your answer, and that is worth 2 marks. So be aware first of all that opposites attract, so that the negatively charged door attracts the positively charged paint. And then the second more difficult answer is to do with the electric field, which touches all part of the car door, and hence the positive paint will coat all parts of the door, thus providing an even coating. A student uses a digital caliper to measure the length of a spring as shown in figure 10. The spring is bendy and difficult to measure. The student takes 6 readings shown in figure 11. Calculate the average length of the spring, and here you're going to have to look out for an anomalous reading, which is this one here. It's far too high, so we need to ignore that one. With everything else though, we're just going to be adding together all of these values. So average length equals these numbers added together, and then divide them by the number of values you have, which is 5, and once you put that into your calculator you get a value which is 20.3. B. The student investigates the stretching of a spring with the equipment shown in figure 12. The student investigates the extension of the spring using 6 different weights, and the results are shown in figure 13. Draw a graph for the readings using the grid shown. So make sure we know what needs to go on each of the scales. So the thing that we're measuring, the extension, this is the dependent variable, it needs to go on the y-axis. The weight, this is what we're varying, this needs to go on the x-axis because it is the independent variable. Make sure you label these axes properly, including their units. So weight is obviously in newtons, extension is in millimeters, and now pick your scales. So it's going to go up on the weight x-axis in 0.2, and then we go up in 4s along the y-axis. Double check your numbers, make sure that it's actually plotted correctly and accurately, and then we're going to use little crosses to show the points on the graph. And we can see a nice linear relationship. So use your ruler to connect the points. The student writes this conclusion: the extension of the spring is directly proportional to the weight stretching the spring. Comments on the student's conclusion. Directly proportional would mean that as the weight increases, the extension increases. Yes, it does. According to our graph, we can see that very clearly. It's a linear relationship and it passes through the origin, which is this point down here. So yeah, we agree. I agree with the student's conclusion because the graph line is straight and passes through the origin. C. The student extends the investigation by finding information about the stretching of wires. The student finds the graph shown in figure 14 for the stretching of a wire. Describe the non-linear stretching of the wire shown in figure 14. So when you're describing, you need to say what you see. So let's have a look closely at this graph, and you can see that above 37.5 newtons, there are large increases of extension for smaller increases in load. The maximum extension of the wire is about 16.5 millimeters before it breaks, and above 12 millimeters, the wire keeps on extending when the load is reduced below 46 newtons. So they're looking for quite detailed answers here. Six, wooden trucks on a toy railway have permanent magnets that hold the train together. The magnets are arranged so that a north pole touches the south pole between each truck, as shown in figure 15. Oh, I used to love these train sets. Truck Y is removed from the train, turned through 180 degrees, and then is replaced between truck X and Z. How does this affect the train? Hopefully you can see that these poles would reverse, so you'd end up with two south poles next door to each other, two north poles next to each other, and therefore they would repel, which is why D is the correct answer here. Y now repels both X and Z. B. The structure of a truck seen from above is shown in figure 16. The permanent magnets cause a magnetic field both inside and outside the truck. Which of these correctly shows the field inside the truck? Now make sure you're aware that the magnetic field always runs from north to south, and it's worth learning the magnetic field lines of bar magnets, of a solenoid, etc. And so when you take all of that into account, the answer here is C, so probably the least complex diagram of all. C. A student investigates the forces between the trucks in the toy railway. She places another truck, W, next to truck X. She pulls truck Z in the direction shown by the arrow. The whole train travels at a constant speed as shown in figure 17. The student repeats this method of adding trucks and pulling the train each time. When there are 7 trucks in total, the train comes apart between Y and Z when tested, as shown in figure 18. So it looks like it's too heavy, basically, for Z to be pulling the rest of the train. Explain why the train acts in this way by considering the forces involved. That is worth 2 marks. So let's consider the forces acting on the train. And obviously where the wheels touch the track, you're going to have a frictional force along here. And this is going to increase as more trucks are added, and that's due to an increase in their weight. And therefore, in order to keep the trucks moving, the student has to increase the force she applies to Z. And so when these frictional forces increase, clearly the student has to add a greater force in order to pull that train. And when Y and Z separate, the frictional forces are more than the magnetic attraction between Y and Z, and that's why Y splits away from Z. Devise an experiment to investigate the horizontal force needed to separate the trucks from the engine. So obviously we need a way of measuring this force, and we're going to use a Newton meter to do that. Crucially, you need to hold it horizontally, and that's because if you look at her hand when she's pulling the train, she obviously needs to pull it horizontally. You use that Newton meter to record the largest force produced, and then, as with all experiments, you want to repeat and calculate an average. Explain why a larger force is needed to separate the trucks from the engine if the force is applied at an angle to the horizontal. So they're saying that instead of pulling the truck to the right horizontally, if you decide to pull it at this angle, and that's all to do with resolving forces. The applied force must be resolved horizontally to determine the force that separates the engine from the trucks, and since the size of the resolved force is always less than the size of the actual force, then a larger force is needed to separate the trucks from the engine. (7a). A straight piece of wire is 0.173 meters long. It is placed at right angles to the uniform magnetic field of 0.47 Teslas. The force on the wire is 0.089 newtons. Calculate the current in the wire and use an equation from the formula sheet. Give your answer to an appropriate number of sig fig. So let's identify what we have. Well, we have a force, we have length, we have the magnetic flux density, and we're being asked to calculate the current. So looking at your equation sheet, this is the equation you need, which states that force equals magnetic flux density times current times length. So let's substitute in what we have. Well, we know the force on the wire is 0.089. The magnetic flux density is 0.47 Teslas. We're after current, which is given as I, and our length is 0.713. So let's sort out the right hand side first of all by simply doing 0.47 multiplied by 0.713, and you get 0.33511. To get current by itself, you need to divide both sides by 0.33511, and that gives you a current of 0.2655 blah blah blah. Let's give that answer to two significant figures, that's 0.27. B. A student investigates the relationship between the magnetic flux density and the electromagnetic force on a current carrying wire. The student has the equipment shown in figure 19. The student varies the number of magnets and measures the force on the wire using the force meter. The results are shown in figure 20. The student decides that his equipment is not sufficiently sensitive. Give 3 ways the student should develop his investigation to improve the quality of his results. So if you look in the table, you can see the reading on the force meter is far too low. So that could be an issue with the force meter not being sensitive enough, and that this actual circuit doesn't produce a strong enough movement in the wire, so the motor isn't strong enough, and that could be to do with the magnets here not having a strong enough magnetic field. So how could we improve all of this? As I've said, use stronger magnets, use a better force meter, so use a force meter with smaller range of readings. And the last thing they could do, which would also increase the reading, as well as having stronger magnets, you could increase the current in the circuit. C. Figures 21 and 22 show different voltages that can be applied across a wire. Explain which of the voltages in figures 21 and 22 cause an alternating current in the wire. And for it to be an alternating current, it means that the direction of the current needs to continuously change direction, which means it needs to dip into both the positive and the negative voltage values, which is why figure 21 shows an alternating current. A power transmission wire hangs so that it is at right angles to the Earth's magnetic field. Although this magnetic field is constant, the cable experiences a changing force. Explain why the force experienced by the cable changes. Hard question here, because this is even more complicated than a normal answer stating the motor effect. We need to first of all describe why there's a force and then talk about why it constantly changes. So start by writing that the transmission wire carries an alternating current. The force on the cable is created by the current, which varies in both its size and its direction due to the fact that it's an alternating current. The stronger the current, therefore, the greater the force experienced. Figure 23 shows an electric car connected to a battery charger. The car has a rechargeable battery to drive its motor. The rechargeable battery provides a potential difference of 330 volts and can store up to 64 megajoules. That's a voltage value. This is energy. So essential you label these because these questions are so hard. It takes 8 hours for the battery to receive a full charge. There's your time. Assume that the charging process is 100% efficient. Calculate the total charge that flows while the battery is being charged. So we're looking for charge. This is the triangle we need to use, which states that energy equals charge times voltage. So charge is given by Q. In order to work out charge, we need to do Q equals energy divided by voltage. Our energy is 64 megajoules, so we need to convert that to joules by doing times 10 to the 6th. Our voltage, we've been told, is 330. When you pop that into your calculator, you get a value which is 193939 coulombs, which is 190,000 coulombs to two significant figures. Calculate the average charging current. This time you need to use this formula triangle, which states that current given by I is charge divided by time. We've just calculated Q. I'm going to use my unrounded number for accuracy's sake. Time, we've been told, if we look up, is 8 hours. Careful with your units, that needs converting to seconds. First of all, convert it to minutes by multiplying by 60, then multiply by a further 60 to get it into seconds. This gives you a value which is 6.73. C. The battery charger shown in figure 23 is connected to the 230 volts alternating current domestic mains supply. The output voltage of the charger is 335 volts and it provides a direct current charging current. Charging stops if the charging current exceeds 15 amps. Explain how electrical components in the charger can be connected together to give this type of output. So hopefully you can see that we are altering the voltage coming in and out, which means we need a transformer. And because we are increasing the voltage, we need a step-up transformer. We also need to look at the type of current. We're going from alternating current to direct current. What we need, therefore, is the diode, which is a type of component which only allows current to flow in one direction only. So a diode is definitely going to be necessary. We need to be careful that our current doesn't exceed 15 amps, and that's where a fuse is going to be useful, because remember that limits the current that can flow through. And lastly, we need an output of energy, so we're going to use a battery to do that. So these are all our ingredients. It is a difficult question, it's worth 6 marks, so I'm going to go through the sequence of events needed. A step-up transformer is needed to increase the voltage. A diode is needed to change the current from an alternating current to a direct current. The charging current can be limited to 15 amps using a fuse. Let's talk about how these things are all going to be connected, and that's through the use of a series circuit, so one after another. Really horrible question. 9. Figure 24 shows a submarine underwater. The motion of the submarine turns the gear wheels shown in figure 25. Gear wheel A has 30 teeth, gear wheel B has 20 teeth. Gear wheel A rotates clockwise through one complete turn. Which of these is correct for gear wheel B? You actually need to imagine it. So imagine it with its teeth here. It's 30 teeth, which are going to basically slot into the teeth of gear wheel B and cause it to turn. And you need to think about this distance here and how the circumference of this circle is much greater than that one. So it's turning this way, and as the teeth on gear wheel A lock into the teeth on gear wheel B, hopefully you can see that this is going to cause that gear wheel B to turn in this direction, which is obviously anti-clockwise. And it will have turned far further than gear wheel A will have turned in a single turn. It will have turned 1.5 turns. So let's have a look at which option is correct. You can see that that is B, 1.5 turns and anti-clockwise. B. A bubble of gas escapes from the submarine. The volume of the bubble is 23 centimeters cubed. The pressure of the gas inside the bubble is 297 kPa. The bubble rises to the surface without changing temperature. Calculate the volume of the bubble when it reaches the surface. Atmospheric pressure is 101 kPa. Use an equation from the formula sheet. So here's our first volume, so I'm going to label that B1. Here's our first pressure, so that's going to be pressure 1. We're being asked to calculate the volume of the bubble when it reaches the surface, which is why that's volume 2. And we've got the pressure at the surface of the water, which is why that's P2. Looking at your equation sheet, which states that V1P1 equals V2P2, have a look at your equation sheet and you'll see this is the equation you need. V1P1 equals V2P2. Our volume 1 we've been told is 23 centimeters cubed. The first pressure is 297 kPa. Our volume 2 is what we're after, and our pressure 2 is atmospheric pressure, which is 101. Sort out your left-hand side by doing 23 multiplied by 297 to get 6831 equals 101 V2. To get V2 by itself, divide both sides by 101, and therefore V2 equals 67.633, and therefore that is 68 to 2 sig fig. C. A student is interested in the way that submarines are controlled. She has several regular wooden blocks, a set of weights and a tank of water. Wood floats in water. The student plans to immerse the wooden blocks fully in the water and investigate the relationship between the upthrust and the weight of water displaced. Describe how she should determine one of the variables in this investigation. So if we look at what she's interested in investigating, it's the relationship between upthrust and the weight of water displaced. So pick one of those variables. Personally, I think working out the upthrust would be the easiest thing for her to do, because if she manages to get the wooden blocks to sink and she works out the weights needed to cause the blocks to sink, she can calculate the upthrust by adding together the weights needed to cause the block to sink with the weight of the blocks themselves. D. Figure 26 shows the submarine stationary and submerged at a depth of 10 meters. Explain how pumping water into and out of the buoyancy tank affects the depth of the submarine below the surface. So let's first of all talk about the forces acting on the submarine. So that will be upthrust, which is the force on an object in water, and then acting downwards will be the weight of the submarine itself. If the weight is greater than the upthrust, clearly the submarine will sink. If the upthrust is greater than the weight, then the submarine will move upwards, and if they're equal, then it will stay in the same place. So if we can look at how pumping water into the buoyancy tank affects the depth of the submarine, if you increase the volume of water in the tanks, it increases the weight of the submarine but has no effect on upthrust. Obviously, if you decrease the volume of the water in the tanks, then it decreases the weight of the submarine. And if that weight is increased high enough, then it will cause that weight to be greater than the upthrust, causing the submarine to move downwards. Equally, if the weight decreases and it becomes less than upthrust, then the submarine will move upwards. So much to write, it feels like a biology paper. So I'm just going to write everything I just said. Question 10. The espresso machine shown in figure 21 is an electrical appliance. The espresso machine has an electrical heater connected to a 440 volts main supply. The power of the electrical heater is 3.5 kilowatts. The rating of a fuse is the current above which it melts. Which of these is the most suitable fuse for the espresso machine circuit? So we have voltage here, we have power. We're trying to work out what the current should be, so actually we need to do a little calculation to work out current, so then we can select the appropriate fuse. So PIV is the formula triangle you need this time, whereby current is power divided by voltage. The power we've been told is 3.5 kilowatts, so I'm timesing that by 1000 to convert it into watts, dividing it by 440, which is our voltage, so that's 7.954, so we need a fuse which has a current rating slightly higher than that, and as we look we can see that that would be 10, so C. Part 2. The specific heat capacity of milk is 3840. The specific heat capacity of water is 4200. The specific latent heat of condensation of steam is 2260. The temperature of the steam is 100 degrees Celsius. The mass of the steam that condenses is 25 grams. The temperature of the milk rises from 5 degrees Celsius to 65 degrees Celsius. By considering the transfer of energy from the steam to the milk, calculate the mass of milk that is heated by the steam and hot water. Use equations from the formula sheet. This has to be, without doubt, the most disgusting question I have ever seen in all my time as a tutor, a teacher. What on earth are you playing at Edexcel? This is a nightmare. Anyway, we need to look at what energy is being transferred to the water to make steam, and this will then equal the energy that the steam transfers to the milk. So first we need to heat the water, and the energy required for this is calculated by using energy equals MC delta T. So that means energy is mass times specific heat capacity times the temperature change, and we're using that equation from the formula sheet. Then we need to continue supplying energy as it boils, and then we need to use a different equation, which is that energy equals mass times latent heat. So effectively, we're trying to turn what I've just said into equations. So let's first of all make them into word equations. So energy required heating water plus energy required for change in state equals energy required to heat the milk. And now let's convert that to an actual equation that we can substitute numbers into. So that's going to be mass of water times specific heat capacity of water times the temperature change of water plus the mass of water times the specific latent heat of water equals the mass of milk times the specific heat of milk times the temperature change of the milk. Now we're ready to pop in our numbers. So the mass of water, well, we've been told that that's 25 grams. We need to divide it by 1000 to convert it into kilograms. The correct units here is crucial. The specific heat capacity of water is 4200. The temperature change is going to be 100 degrees Celsius minus 65 degrees Celsius, which is 35 degrees, plus the mass of water, which is again 25 grams, converting that to kilograms. Be careful now with the latent heat of condensation of water. Look at these units. That's in kJ. Everything else we've been given is in terms of J. They are being so horrible here, which is why we need to take that number, 2,260, and times it by 1,000. And then the mass of milk on the right-hand side, that's after all what we're after, so I'm putting that as X. The specific heat capacity of milk is 3,840, and the temperature change of the milk is 65 degrees Celsius minus 5 degrees Celsius, which is 60 degrees Celsius. So let's sort out the untidiness on the left-hand side. When you sort out the first bracket, it becomes 3,675. The second bracket is 56,500. And then multiplying together, 3,840 by 60 gives us 230,400 X. Again, tidy up the left-hand side. Tidying up the left-hand side gives us 60,175 equals 230,400 X. Divide both sides by 230,400 to get X equals finally 0.26 kilograms. And honestly, I can't see anyone really getting that question right, so try not to panic too much. There's plenty of other available marks on the paper. Give 2 reasons why the actual mass of steam needed to heat the milk from 5 degrees to 65 degrees is greater than 25 grams. So really, where must some of that steam have gotten lost? Well, firstly, more steam must condense and transfer the energy needed to cause the milk to froth, and more steam must condense to replace any steam that might leave the milk without condensing. So that is still quite a hard question to end this paper on. And that paper is finally done. Pretty horrible, not going to lie. Those calculations, I can't believe how many different equations you're going to have to use. Please make sure you've learnt all the essential equations and know the standard SI unit. That, my friends, is key. Don't forget to like and sub if you haven't already, and I'll be back soon.